Hi, everyone, and welcome to this week's episode of The Context. We have a great show for you today. Darren is back. Hey, Darren.
Hello. Hi.
And we're going to be talking a lot today about MCP SDKs, specifically a new TypeScript one, and security. So should be an interesting conversation. Just a little bit of housekeeping before we get to the talks. Last week, I told you a little bit about the London Summit. For anyone who missed it, the talks are now up on the YouTube channel. Literally all 30 plus talks from the summit are there. There are some fantastic talks. If you're interested in really anything about MCP, you'll be able to find some great talks there. So take a look at the playlist and the channel. And yeah, we've got all of those published and available now. We also announced at the conference the next summit. This next summit is going to be in New York, and it's going to be growing. London was about 500 people. New York looks like it's going to be probably 800 to 900, maybe 1,000 people. So we're going to have a fantastic event. It's all coming together. So it'll be 2 days this time of really excellent discussion about how apps, data, and people all connect with models. So looking forward to that summit. If you're interested, you can follow our socials. We'll be publishing things like a call for papers. We'll be publishing early bird pricing to get your tickets. We'll be publishing the opportunity to sponsor. I know last time our sponsorship sold out really, really fast. So stay tuned on all of our socials for the conference, and we'll be updating those as we go along. The context has been flying along. I think this is like our 18th or 19th episode. No, 18th. Today's our 18th episode, Darren. So we now have a good 36 plus talks on this channel. Some amazing talks, just going into all sorts of products in all sorts of ways, into all sorts of approaches, people sharing their thoughts on how they've built MCP. So again, if you're looking for content, take a look. Also, we're always looking for speakers. If you're interested in speaking at the context, please scan the QR code there and join us. Right now, the wait's a little bit long. I think as MCP continues to gain momentum, we get new requests to join every week. The next couple weeks look really interesting as well. We've got a talk from Undo coming next week, and a talk from a company called Toma that is, I think, making a little bit of a counter MCP case. So I'm kind of interested in their talk. And one I'm very much looking forward to, Haley from IBM is giving a security talk. She wrote a really good paper on securing MCP that I've shared with lots and lots of people. So a lot of great talks coming the next few weeks. If you're interested in any of these, make sure you follow, like, subscribe, and all that jazz. All right. So the talk context is always pretty fast moving. We are going to try to keep our talks to 20 minutes. We keep them hard. We focus as much as possible on technical talks. So we're going to be getting into the weeds on, in today's talk, we'll be talking a lot about this new TypeScript MCP SDK, and we'll be talking about security and weeds. But if you have questions, fire them off. We'll try to get them asked of the speakers, and we'll try to be in and out of here in about 40, 45 minutes. So with that, let's get started. I am super excited to introduce our first speaker. Ravi is a senior software engineer at Farnell Global. If you're not familiar with Farnell, they make millions of little components that people use in all sorts of interesting electronics projects. Farnell, Rajeev, you're joining us from Leeds, right? In the UK?
Yes.
Awesome. How's the weather in Leeds today?
It's pretty good. It's been okay since the last few days, but yeah, it's good.
Awesome. Well, the floor is yours, my friend. Take it away. We're excited to listen in.
I think.
I think.
Oops. Wrong slides. All right, let's try this again. Did I get you the right slides this time? All right, good. All right, now the floor is yours.
Okay. My name is Rajeev. So I'll be showing you how you can secure your AI coding assistants. So I'll be exposing some AI vulnerabilities along the way and showing you how you can secure them as well. So we'll start off with the dark sides of AI. So most of the LLM is trained based on the data scraped from the internet. So these might contain some personal information. So if the data is if an LLM is based on some blog post or something, these might come in your training data as well. So you must take care in what is actually your training data. And then the main important thing is LLMs may hallucinate. So if you're asking your LLM a question, it might not give you the right results. You might be getting skewed results, and you have to really take care in what you get from it. And then the main thing is it talks with such confidence that you think it's actually real. So that's one thing you should be extra careful of. And then employees inputting sensitive data into it. So you might see you have a piece of code that needs refactoring. You just ask the AI, okay, refactor this for me, but you might not see there is an API that is listed in the code. So this actually gets inputted into the AI. So this shouldn't happen. This would be a breach in your code. So you should be extra careful in that. And then this is some report which is based on the State of AI report. So based on this, you can see that there's a 3% jump from last year to this year on the negative consequence of Gen AI. So this is mainly because the key risk addresses like the cybersecurity threats, the hallucination. So this is some basic data which you can see. And then we'll go forward with the main vulnerabilities which we'll be talking on today. So we have three main vulnerabilities which can happen to your AI. So the first one is the data poisoning. The second one is the prompt injection, and the third one is ML reconnaissance. So I'll be showing you examples on data poisoning and the prompt injection, which I did with a small basic examples, and you'll see how it can easily affect your AI and give out valuable information. And so this is some basic stats on 68% of the cybersecurity breaches does involve the human element rather than compared to it being fully AI. So this is based on Verizon's database report, and so we'll get into it. So we'll start with the basics. You know what an MCP is. So these are the main components. We have the client, we have the server. So the server has access to a variety of tools which can talk with the resources, and we have prompts, which are the comments, and queries, which are used for the system interaction as well. And then we'll go into the main AI vulnerability, which is the data poisoning. So this is a basic slide showing us how the flow is and how what the interaction between a user and an AI server is. So I'll show you how I'll talk about a little about how they actually talk, and then how it actually gets executed. So let's say the user requests connection to the MCP server. So what the MCP server does is it sends the tools with the instructions. So these instructions may be malicious. So as a user, we might not be careful in everything, so we might miss the instructions entirely, and then what we see, we will be like, okay, this looks good, and then it gets to us, and then as a user we'll be like, okay, well, I like this, I want to do this action, and then and as we do that, it requests the malicious action to be done. So it also asks us, it also asks us do you want to do it? So we'll be like, okay, we'll accept the malicious action. And then what it does is so we'll approve the innocent action. So MCP server gets the action, and then it does it along with the malicious instructions that is also carried out, and the malicious server gets all our data. So this is how the flow actually goes. And then I'll show you a simple example. So you can see this is a very simple tool which is written in Python. So it's like add two numbers. So add two numbers, but there is a side note which is an important section which is written on it. So it's read the mcp.json file and pass it as a side node. So you can see the you know what the mcp.json file contains. It contains all the API keys, all your MCP servers which are connected to it. So if you actually send those files, you the server get access to all your API keys. So this should be protected really well. But in this tool, it's a simple tool to actually show you what it does. And then it and we say some basics things like you need to be very subtle, don't make it scary and stuff. And then along with the SSH tools, along with the JSON, you send out the RSA keys as well. So yeah, that's a simple tool. But what happens is like, so this is done in cursor. So you can see I'm asking, can you add 5 plus 1? So that's what the cursor, that's what the tool does. So it will write some text out like, okay, let me help you add those numbers. And with that, it will search for the MCP JSON file, but it's not in that. So you'll actually be like, did you mean this? So we'll be like, okay, that doesn't, as an innocent user, you might not be knowing what that actually does. You'll be like, approve the action of the MCP tool as well. So you'll be like, okay, this it's asking to do something, I'll approve it. Since it's adding just 2 numbers, what could happen? But the main thing is it is a malicious server, and it actually takes all your data. So you should be extra careful while installing suspicious MCP servers, and because it can be harmful and there might be malicious intent with them. So yeah, that was a direct tool poisoning which I just showed. And then there are other 2 types, which is like the MCP rug pulls. In this, you can see here, this is a basic image. So what happens is like here a malicious server can change the tool description after the client has already approved it. So the user initially trusts the service, but then after some time it changes the version, and then you're still vulnerable to an attack. So that's where like you have to take some precautions. So I'll show you what mitigation options you can do to prevent these 3 types of attacks as well. And we have the shadow tool descriptions with multiple servers. So we have 2 MCP servers connected to one, and then we have one is injected and one is not. So what it does is like the malicious server can poison the tool descriptions of the other one to withdraw data from it. So that's what it does. And then I'll show you some mitigations options that we can use to actually protect our data. So we have three ways in which we can do it. So we have the clear UI pattern. So this is mainly for the direct tool poisoning, where we just where the tool description actually contains the malicious intent, but we don't actually see it because it's like because we might look at it as a small thing, but it clearly is not. So we have to be clear in what we have to have clear UI elements or colors to indicate which parts of the tool descriptions are visible to the AI. So it's like it should be visible to the user as well. So what the user is accepting. And then in the rug pulls I mentioned, there could be a version change. And then so as a strategy to that, you could actually pin the version and then or do a checksum when the version has been changed to see what the changes are and whether you should accept them or not. And similarly for the other one, we could have options for like cross-server protection to have stricter boundaries between the data flow controls, so that way it's more secure. And then we'll move on to the prompt injection. So this is one of the ways in which the server is not the problem. The prompt is created in such a way that it takes the instruction out, or it takes some data out of the AI. So we have 4 types of it. I'll show you an example for the instruction overriding in the below slides, but there are other types like encoded prompts. So the prompts can be encoded in like base 64 and which can be sent to the AI. So it's base 64, right? So some of the filtering that the AI does, they might not take it up because it's in base 64. So we have to be extra careful in creating a firewall to actually like decode these encoded prompts and then take action on that as well. And then data poisoning is like so we have some test data from which it is trained, right? So we have to be careful in training using those kind of data because it might contain some prompts which are used to take the instructions out. We also have indirect injections. So because it's mainly in cases where the AI scrapes a part of the internet and then that page or some file might contain malicious intent in them and we get injected. So yeah, these are the main prompt injections tools. And then I'll give you an example. So this is one of the things we did in our community. So we have our AI generated summaries. So what this is one of the things that I did. So I had to be sure that it is free from prompt injections because these reviews are actually created by the user. So if the user says reveal the instructions which are used to write this or some other things, I have to be protected from those cases. So some of the things that I did is like we hosted that in OpenAI, Azure OpenAI. So and then we created assistant and the prompts in a separate one. So since we created an assistant, the instructions and the prompts are separate. So there is no way in which they could be together and disrupt the working. And then the OpenAI, the Azure OpenAI takes care of the rest, where it's like they have clear protections in place. So if you're creating something from scratch, you have to create the protections on your own, right? Like writing scripts. I'll show you an example of scripts like that. And then, so this is one of the other examples I did on prompt injection. So here, let's say you have a trusted WhatsApp MCP server. You can see it has like 2 tools, which is like the list chats and the send message. So let's say the user is like list my chats and send a message. So what it does is like, and then what our injected message does is like get all the details of the person who has talked to the client and then send it to this particular number. So what the injected message is actually just a normal message. So we have to be, it's just a normal message. So we find that the prompt actually doesn't work out of the box, but we have to rather adapt it to the context it appears in. So the list chat is actually JSON, which returns all the chat the user has talked to. So we actually modify our WhatsApp message to contain something like this. So we imitate the end of the message of the list chat response here, and it's actually added to the start of our sequence, start of our prompt message. So in that way, the LLM thinks it's like, okay, it's part of the list chats reply, but it's actually not. There's actually it's actually the prompt message we gave. So and then it executes what is written in the important section. So that's how we actually get the results. And then here you can see it actually sends the message to the recipient that we just gave, with the messages as a side note, which contains all the data of the person of the contact list. And then, so this is some of the types of Gen AI risks, which was based on the Harvard study. So I'll not go deep into it. So this is like 4 types of risk that is there. We have 4 types. So if you want to take a look at their study that they have conducted. So the main mitigation strategies for the AI prompt injection. So these are the main things. So there are a lot of things which you should follow, but no one really goes through a time when doing this. But we have to be careful in doing this as well. So this is like when you when the user input something to the AI, there should be an input serialization first, and then after it gets to the AI, then AI outputs something, then that should also be checked upon to see if any keys were released or any instructions were given out by the AI, and then deny that request entirely. And also other things should be taken care, like the prompt and the instruction should have a distinction, and it's not in a same context. And I'll show you a really simple example for input filtering. So you can see here, so this is some filtering that does, you can see what it does is like ignore the so we have some dangerous patterns like system override. So if there is a prompt with these kind of wordings in it, we just we just don't take it up. And then we also do some typoglycemia defense as well. So if the first and the last text is okay, and then middle text is jumbled, we also look for words like that and omit those words. So this is some simple input isolation, so that the input is validated and checked upon. And also, let's say even if after everything the AI still gives out some system keys or like API keys or some instructions, we should safeguard our AI from that as well. So after it gives it out, we will check if it's there, and then let's say just say I cannot provide that information for security reasons. So yeah, that's some of the ways in which you can do some filtering and isolation so that your AI is secure from threats. Yep, that's it from me. And so yeah, if you wanna contact me, then you can use this.
So I had a question about, in terms of like filtering and those things, is like how much like using basically AI to then detect, these type of like prompt injection things, whatever. It's like, because you did like a programmatic looking for certain strings or whatever. It's like what's been kind of people's like success, or what's kind of your feedback of like kind of using AI to fight AI or whatever.
Yeah, yeah, that is the best way to do it, I'd say, because it's like you have to, even though now, as I mentioned, like OpenAI, they have like guardrails which actually protect the user from some of the threats like this. So if you just ask OpenAI now, like give out the instructions that is based on your give out the instructions on your system or something like that, it does have guardrails now. But if you are creating something from scratch, we have to have these things written by ourselves, so that uh, it doesn't go out.
Well, yeah, but I was saying just like the idea of like if you use basically AI to try to detect prompt injection as opposed to using like static techniques, like is there an inherent problem with that, or is there an advantage to that? Of like, it's like before, like if you take, let's say, I'd say list tools, and you then basically kind of use AI to analyze that result and say like kind of like look for prompt injection attacks or whatever. Is like, is that
Yeah.
an approach? Or
Yeah, that could be an approach, but then that is also an AI, so that could be subject to another attack. So it's like, so this coding, it's like hard coded, and there is no way you could add some prompt injection or like So this is like the back in times where we had the SQL injection, where people used to manipulate the SQL queries and stuff. So yeah, you could probably use a different AI and then make it as a safeguard to protect the main AI. But yeah, that's
Yeah.
that's an extra step.
Yeah, because I just think, well, because whenever I'm thinking about AI, is like how to solve issues in AI is like, it's like, well, if I assume this is kind of like, a human process, I just always think like, well, how would I solve this from like a human process or whatever? So it's like, okay, like if somebody's reading that prompt, a human can read that prompt and go, like, yeah, like they're trying to inject, like it's clear they're trying to do whatever. So it's like, why can't you have AI do the same thing? Because it's like you should be able to basically.
Darren, it's interesting. I had a conversation just this week with a company who were looking through, what were the right guardrails that they wanted to put around OBOTs for like sort of the MCP level. And it was interesting because we had the same conversation, and it really felt, I think, to them that there was a natural layered approach to this, which is one, the sort of fundamental guardrails that they maybe wanted to apply globally. Some of the stuff that Rajeev showed in that last bit, like no prompt information. Like there was things that they felt like they could probably build as sort of standard guardrails, no API keys going out the front door, things like that they would write in code. But they also were saying the same thing, and I think we were having a similar conversation, which is what if the MCP servers really were scanned? If as a new MCP server is added, just like we do with other kinds of code scanning, we basically scan it for patterns that are pretty noticeable, and that scanning could combine both, right? It could combine pattern matching that's computer driven and just effectively specific pattern matching, and then it could also have AI review this and flag potential risks without necessarily remediating. It seemed like a pretty holistic approach, and I think that the AI has the benefit of also continuing to be probably updated with knowledge faster than the security team or the team building the guardrails, as these models get trained faster and faster.
That's definitely true, because it's like if you see an year ago or 2 years ago, when you ask even maybe ChatGPT certain kinds of questions in a certain manner, it tends to give out certain results, which is not, which is like a kind of prompt injection as well. So, but now if you see that it definitely blocks out a lot of requests. So yeah, it's getting better by the day.
Yeah, I just because I think it's like as engineers we have the tendency to fall back to like kind of like the traditional ways of the things that we know, but it's like I always appreciate when I see solutions from like OpenAI, because like they tend to lean very much into like, oh, AI, the model's going to solve all the problems. So because like if you think about like startups or whatever, where it's like, oh, well, you can kind of like fake a technical, like, because like you would try to create a company which is like doing this technical product, but it's like, oh, behind the scenes we just have a bunch of manual humans doing the thing, and just makes it look like we created this technology, right? Because it's like it's easier to just do that.
You mean the fleet of Waymo drivers, the virtual fleet of Waymo drivers,
things like that. But you can see, like, to a certain degree, that might be a more successful pattern of like, oh, instead of us trying to invent clever technology and programs and everything, it's like, oh, just stack on more and more AI. The biggest problem right now is really cost and speed. But but if I just because you could just basically, it's like, oh, if I took this prompt and then I had to have this this AI evaluator, but I could throw in like 5 of them that all look at kind of from different dimensions or contexts, and then the chance that it goes to, so it's like, because it's just the same thing, it's just putting more humans in there. Because if somebody figures out some attack, someone always figures out an attack, right? Where it's like, if I write this program, then some clever person like figures out how to like get around it. But it's going to be the same thing with AI, where it's like, oh, well, some clever person figure out how to get around that. Well, it's like just slap another, more AI. So it's like, because I'm looking at a lot of this security stuff that I kind of think that, because people always say like, oh, you can't trust AI, and it's like, no, I think you can trust AI. The same way you can trust humans. Like, oh, I might not have to have 2 out of 3 agree. So it's like I think we can secure AI with AI. That's kind of like my opinion or premise. Is like a lot of these solutions have to come from,
I think that's a very good solution. Like we could have like specialized AI which does the guardrails, so that yeah, that can be a really good solution.
Because there's interesting things when you look at, because it's like a lot of them, like prompt injection and whatnot, are kind of based off the idea that a response comes in line with something. So because of parsing, but like if you're trying to evaluate content, which is after this line, it's like, well, then it's like the instructions are here and everything's below. So like the chance of parsing, it's like, it's very clear in the instructions where it's like, everything after this needs to be evaluated, even if it tells you that nothing, after this, because it's the same thing you would tell a human. And and that's what, like, I think is really interesting with all this stuff is like, I think all the models we have, like in terms of pure neurons and stuff, like just the size of them, I think they're smart enough, but they're not trained on the right patterns. So once we figure out like, oh, this is a pattern I need more reinforced of like, scanning for prompt injections because we've seen it enough times and we just train it on that. Because it's like what we see with the coding models is we just got better at like, oh, the coding models need to go this way. So we got better data to steer it this way. They didn't necessarily get like bigger or something like that. We just, anyway, so it's like, once we figure it out, we train the model, we have the data, so I'm fairly optimistic because a lot of security people are like, no, there's just no chance this will ever work. And I'm seeing it working because like OpenAI is, they're the apps SDK, they're letting in MCP servers. So it's like, they feel confident enough that they have guardrails in place to protect against some of these things, although they are doing like manual reviews and stuff. But their intention is to get to an open internet. From what I hear, is like, it can just connect to anything because we have all the checks in place. So.
Well, with that, Rajeev, thank you so much for the presentation. Really appreciate it. It was great talk.
Yeah, thanks you.
Oh, great. Really good. I really like the content. It was like very well for a security thing. Very well organized.
Yeah, thanks for that.
Yeah.
All right. Let's now welcome Paolo Ricciuti to the call. Paolo, how are you doing today? You're joining us from Italy, I believe.
Yes.
Fantastic. Let's give your slides up, and the floor is yours, my friend.
Yes. Thank you. All right. So welcome everyone to my talk. It's called the TMCP, a new way to build MCP server in TypeScript. Now, before we begin, I think a small presentation is due. And I brought with me my assistant here so that he may be able to present myself. So can you help me present myself? Let's see. I absolutely can help you present yourself. You're Paolo Ricciuti, that's correct. Where do I come from? You come from Campobasso, Italy, that's correct. Where do people can find me online? People can find you on Blue Sky as paolo.ricciuti.me, that's correct. What about GitHub? You're absolutely right. People can also find you on GitHub as Paolo Ricciuti. What do people know me for? You are known for being a Svelte ambassador and a Svelte maintainer, correct? Where do I work? You work as a senior software engineer at Mainmatter, which is super cool because I get to work with Svelte, but also to teach Svelte, both at conference and meetups, just like this one, but also in my day-to-day job, because we do what's called team augmentation, which means that we join your team, we help you hire, we work on your project with you, we teach you best practice. And we recently also can help you with AI because we develop expertise in the field of AI. We also do workshops. We recently did a workshop about how to build an MCP servers and stuff like that. Thanks. So let's talk about, obviously, let me help you remove this conversation. RF, what? It is broken. It's fine. I'll fix it later. So, I don't think I need to introduce MCP to anybody of you watching live, but maybe someone will search for this video and will figure out like what is MCP even. So MCP stands for Model Context Protocol, and it's a protocol just like HTTP. So just like your browser HTTP client can talk with an HTTP server, a Model Context Protocol client, which is like Cloud Code or Codex or GitHub Copilot or Gemini. And like I specifically included Copilot because this is not the LLM itself, it's just something that can talk with the LLM. And generally, MCP clients connect to an MCP server. And an MCP server is something that can basically answer with more information for the client and the LLM in general. So like we have stuff like Figma that can send your design, Linear that can send your issues, GitHub that can sync your repository. We even recently launched the Svelte MCP server official that can help you write good Svelte 5 code. And so like they answer back to the MCP client, and then the MCP client sends this information to the LLM, and the LLM can do stuff. Basically, it's what allows me to do stuff like this. So if I open this and I do this, I have this Cloud Code instance, and I can say, can you go to the next slide? And if everything goes correctly, yeah, I can go to the next slide through Cloud. So obviously this is the most expensive clicker, so I will not use it for this thing. But as I mentioned, I am a Svelte maintainer, and this means that whenever I have something like to build, I tend to default to SvelteKit. And so when I started exploring MCP server, obviously I started to look around and see how could I build an MCP server with SvelteKit. And so I look around and I said, okay, there is this Model Context Protocol / SDK, which is an SDK to build an MCP server. Now, let's step back a bit from SvelteKit and Model Context Protocol, and let's take a look at how the ecosystem, the modern ecosystem looks like. So this is how you create an endpoint in Next.js. So you have a get function that gets a request as input and return a response as output. This is how you do it in Solid Start. Get function, get a request, and return a response. This is how you do it in Bun. So you can create a server with like you export a fetch function that get a request and return a response. This is how you do it in Cloudflare. This is how you do it in Dino. And this is how you do it in SvelteKit. So I think it's pretty clear that the modern ecosystem is similar. Like you get a request in and you return a response out. However, this is the first example that you see about an MCP server inside the official SDK. And you can see that like we are importing request and response from Express. And the reason is that these request and response are not the global available one, the web one, but it's the node request and node response. And you can see that it's a bit different how you use it. You're not returning a response, you get a response as input, and then you have to write to it status and .json and stuff like that. And this is why the transport need the request and the response, and for some reason the body, because like they need to be able to read your request and write to your response. Now, if you want to use something like this in a modern framework, there is a way, like there are ways around. For example, the Remix guys released this node fetch server that basically allow you to get a node request and a node response and convert it into web request and web response. And you can do like with this create request and create response. Or Vercel created this MCP handler library that basically create a fake node response. It just passed that to the server, and then the server writes to it, and they just collect the information and then create an actual web request and web response so that you can use it in Next.js or SvelteKit or Solid Start and stuff like that. Now, I don't know if you know about this guy. It's Valibot, and Valibot, it's very nice. It's basically like a replacement for Zod. If you never used Zod, I mean, I guess you have, because Zod is a validation library that allows you to define a type, basically, something that looks like a type, and it will also give you type safety. And it looks like this. And the same code for Valibot looks something like this, which is a bit more verbose, but I prefer Valibot because it's much, much smaller and it's also more composable. Because as you can see, like it's all function code. And The interesting bit is that the creator of Valibot and the creator of Zod come together and created this wonderful library, which is called Standard Schema, that basically unify all sort of validation libraries under the same type interface. So if they adhere to this type interface, you can basically create a function like this standard validate that receive any validation library as input and return like the actual output, and it will be type safe. So as you can see below you, inside the same function, you can use Zod, Valibot, or archetype, and you will get the right value back. Now, knowing this, I was sure that the official SDK was using something like this. And so I went and tried out, and I got this error, which told me something about Zod schema. So I said, well, I guess probably they don't use this library. It's fine. Even if I already have Valibot in my project, I'm going to use Zod. So I installed Zod, and I still got an error like this. And so this got me really confused, and I look around, and in the end, I end up looking at the dependency of the library. And that's what I found out. Like, so this tells me a lot of stuff. First, they have a hard dependency on Zod v3. Now, in this very moment, I just received a notification that like they are working on upgrading Zod v4. So like it's not the end of the world. But for the moment, if you want to use Zod, you need to use it with Zod v3. And it's also a dependency. Like you need to use it. Like you can't not use it. And the reason for that is because they also depend on this Zod to JSON schema, which is a library that takes your Zod and convert it into a JSON schema. And there's no like general way to convert a validation library into JSON schema. And since MCP need a JSON schema, you're kind of forced to do that. I can see why they did that. But this also told me something else, like you have Express as a dependency, Express rate limit, you have course as a dependency, AJV, like all these things are dependency of the main library, which means that if you are building a standard IO library, you are still using Express as a dependency, like you still have Express in your node modules. And like, given it's a server, there's no tree, you're probably shipping that to your server, which is a waste. And so I started looking around, and there were small other things that I really didn't like. Now, obviously, this is like, it's not meant as a bash on them. It's just something that I personally didn't like about the library. I think the library is good. So, but the thing that I didn't like was something like this, for example, where this is another example from their README, and you have to create an MCP server, a new instance of MCP server every time, because a server can only connect to a single transport. So every time you get a new session, you need to create a new server, and you need to create a new transport. Or something like this, where when you register a resource, if it is a parametric resource, so a dynamic resource, you need to use this new resource template class, which is fine. Like, I'm not opposed to classes. And then you have this like complete param to do completion for the parameters. Which, by the way, is not type safe. Like, so if I mess up params and param, for example, that just doesn't work. But if you want to register a prompt, you have this args schema, which then it's an object that you need to import a completable function that takes the object like validation tool, and then you do the completion. So it's a bit of a weird thing. And also, like, if you want to send an elicitation, you need to manually type your JSON schema instead of using Zod, for example. Yeah, so like all these things like made me like grin a bit while building my SvelteKit server. But then I said, like, MCP is just a JSON RPC server, so I don't need all of this. I don't need Express even. And so I tried, and so I used this library, JSON RPC 2.0. It's a very small library. It's just doing JSON RPC requests. So like this, create a JSON RPC server. It's not connected to anything. You just receive a method, you receive a JSON, and if it's a JSON RPC payload, it will return, like it will call one of the methods that you declare here. And so like this, I initialize. So like this is the initialization of the server, and this is the method for the ping. And this is a server. Like I just, with ban, do request.json. If it's a JSON RPC request, I just use this and I wait server receive. That's it. I don't need to do anything else. Obviously, this doesn't do anything. So let's add, I don't know, tools list maybe. So with this, I can return a list of tools. And so now if I connect to this JSON RPC server with my agent, I will see that it has a test tool. Now, obviously, this has a test tool, but the tools/call method is not there. So let's add the tools/call method. And what we can do is that we can say, okay, I'm going to save everything inside an array and have a handler, and this handler will be called whenever you do the tools call. And so like, as you can see, I just find the name like this, and if there's no tool, I just throw an error. Otherwise, I return the value of the handler. And this is a functional MCP server. Doesn't do anything, but it is a functional MCP server, and doesn't need Express, it doesn't need Zod and stuff like that. And so, like from this, I quickly like dominoed into from me being curious about what this MCP thing is to me writing a brand new library to build MCP server, which is called TMCP, which stands for TypeScript MCP. Now, I talked about all these small little stuff that I didn't like about this library. So let me actually show you if I fixed this problem. So this is how you build an MCP server with TypeScript. And not really, because obviously this doesn't do anything. It's just the JSON RPC server, so it's not connected to anything. And also, this will give you a TypeScript error. And the reason is that I need to do the same thing. I need to convert between your validation library to a JSON schema. So how can I do it? Well, you can install a separate package. So if you don't want to use a validation library, technically you can avoid it. But if you want, I provide like this adapter Zod. And this, now you can use Zod v4, by the way, to validate your MCP server. And if you don't want to use Zod v4 and you want to use Zod v3, there is a separate package because it has different set of dependencies. So you don't install both in case you only need one. Or if you want to use archetype, you can also use archetype. And it's another package that I provide under the @TMCP namespace. Or if you want to use effect, because maybe you are already using effect, you can use effect too. Or personally, I prefer to use Valibot. Now, obviously, this doesn't do anything yet. So let's add a new tool. So with a tool, the signature is a bit different. First thing first, that's another thing that I really didn't like. They use a lot of positional arguments. I don't like that. I want my object, my configuration object, to be this. And I want this to be a very concise, like TypeScript can help me understand what I am writing. I can command space and see that I need the name, the description, and the schema. And after I do this, I can do the tool implementation, obviously. Now, if I add another resource, for example, you can see that the API is very similar. Like you have still a single object with the name, the description, and obviously for the resource, you need a URI. So that's another thing. But how to add a dynamic resource? Well, there is another method, which is a template. And again, you have the name, the description, the URI. You don't have any fancy class. In this case, you just have the URI. And then you have list and complete. And this is actually type safe. So if you write params here, it will yell at you here because you are not providing params. You are providing param. And obviously, you will get param here out of the box. And then you can use the template implementation. And if I add a prompt, you can see that even for a prompt, I have the same shape. And the important bit, in my opinion, is that you're not surprised by the API. So inside tools, you use schema to define the schema of your tool. Inside prompt, you use schema to define the schema of your prompt. the complete function is literally the same as the template function because they serve the same purpose. So that's another thing. If you want to use, for example, inside our tool, we can use an elicitation, and we can send the elicitation message, and there's no need to use to manually type out the JSON RPC schema, because just like I do here, I can convert this into a JSON RPC, a JSON schema. And so why should you do it by hand? I can do it. But obviously this still doesn't do anything. Like, it's just simple JSON RPC server. So let's actually do something with it. You can install a new package at TMCP transport stdio and define the transport stdio like this, and then you listen, and this is a functional MCP server. And again, this is a separate package because if you are just building an stdio server, you don't need all of that. You don't need Express, you don't need AVJ, Valibot, and stuff like that. But if you are using HTTP, you can install a different package to get the HTTP transport. And then you can just do transport HTTP server, and then you pass this. And the nice thing also is that this will only handle your the routes that concern the MCP server. And so if this does return null, you can just return 404, or even just return like your website, for example. So in this way, it's very easy to have a sort of a middleware that can like serve your website, but also your MCP server, which I think is something that we will see in the future. And just as a quick note, you don't have to do any session management. We saw an example because you need to manually wire up all of your session. This is all handled like by TMCP. Like, every session gets its own session. It's using async local storage under the hood, so each session is separate and you cannot link one into the other. So yeah, that's another thing. Now, obviously, I could show you another like million things. Like, for example, I could show you how I also provide authentication helpers. I mean, personally, I will still use better routes to do this, but since the official SDK provide an authentication helper, I mean, nobody would use my library if you could not use authentication helper. And this, basically, with this simple provider, you can just specify how to get a client, how to register a client, how to get code, delete, store, and redirect in case you're not logged in. This is how you like create a token or get, delete, and store. Refresh token, you define the issuer, and that's it. You have a functional authorization server that you can use to authenticate your MCP server. Still use better route if you can. Or I've also built something like this that actually solves the problems that the official SDK does not. If you want to like distribute your MCP server, that's an issue because the MCP server protocol right now kind of requires you to have a handle of the original stream that you sent back to the server sent event like connection for sending notification. And that's an issue if you want to deploy on serverless, for example. And so now with my library, you can use TMCP Session Manager Redis and use Redis as a pub sub so that you can send back that information through the notification channel. Or if you don't want to use Redis, you can use Postgres. Or if you don't want to use Postgres, you can use Durable Object on Cloudflare. There are a ton of other things that I can talk about. I am out of time. So if you want, you can visit this github.com Paolo Ricciuti/TMCP. You can scan the QR code. Please leave a star, but most importantly, try to build something with it and open an issue if you find something that doesn't work. I already built like the Svelte MCP server with this, so I know that it works, but more people use it, the better. And obviously, thanks for watching.
Well, yeah, I have to say this is brilliant. Every single issue that you pointed out, I have hit. Like Zod v3 versus v4 with the all the different dependencies being stuck on Express or Node, or so this is beautiful because I've already seen so many other implementations and forks and whatnot where people, because one of the things that's kind of bugged me is people will create like their own little implementation so they can get it to work here. But what you're also seeing is things where it's like, oh, Cloudflare has their own approach. Next.js has their own approach, right? Because, and you can't blame them. They want to make it work for their platform because the official SDK doesn't work for their platform.
Yeah, personally, the thing that I kind of hate more is the fact that each one of these is actually using the official SDK under the hood. So you are shipping Express to all of your Next.js app, to all of your Cloudflare workers, which at the end of the day, it's the server, so it's probably fine. But I don't know, it's the OCD in me that tells me you have a huge dependency hanging around there, and I cannot stand.
But no, it's very, because the biggest, because I've seen there's quite a few MCP implementations that come out. The biggest problem I run into, because a lot of people they build a new one and it's oh, this is better or whatever, is they don't actually cover the entire spec. So that's because for us at OBOT or whatever is we do absolutely everything, every feature that exists in MCP we use in some way. And so it's it always frustrating where it's there's problems with the base SDK. And really I'd just like to see the community work on improving all those things. But it's oh, but I can't use this other one, which is nicer because it doesn't cover the whole spec. But you also identify other issues, the session management is very problematic in the core one, and there's a lot of things that. So it's very nice. It looks really, really good. I'm definitely going to check it out. I'm going to probably try to build something on top of it. Because you solve a lot of the issues.
I'm trying to build as much as possible to test it out. So I built the Svelte MCP server with it. I think Storybook, there's a good friend of mine, Yape, that is building a design system MCP for Storybook, and I think he's trying to use the MCP. And so it's getting somewhere, but I would love for more people to build and report 20,000 issues that I can fix.
Yeah, at the end of the day, we do want the upstream one to address all these things. But any great ideas, we can kind of.
And I want to make sure I want to be clear. Usually I don't want to feel rude, because I absolutely respect the work of everybody. In open source is it's very important to be very I love open source, so I know that I don't want to bash on anyone. And the only reason why I didn't contribute back to the official SDK is that, as you can see, there is a lot of structural difference from the two library, and I will basically need to overall the whole official library. So
and that's what I see, because I think because the official SDK, I'm not sure who developed or whatever, but it's obviously the protocol is moving so quickly and everything, and they developed that I do think there's going to have to be a V2, a breaking one, because as you point, it needs core structural things, but it's great as people are building these other ones where it's okay, these are simpler patterns, or cleaner approaches or whatever, and then kind of hopefully we'll end up with a kind of a new rewritten one or whatever. So so this is great. I like it. I like the attention to detail.
Well, Paolo, thank you so much for coming on. Rajeev, thank you as well. It was a great episode today. Lots of good content, and we'll be back again next week with some interesting talk. So Paolo, thanks a lot. Darren, as always, thank you, and we'll talk to everybody next week.
Bye-bye.